Okay, hello and welcome everyone to Engineers Ireland Digitalisation in Engineering. My name is Michael Gallagher. I work for Engineers Ireland and I'm delighted to be your host this evening. We have a really exciting agenda coming up, and before I get to our two main speakers, just quickly to talk on behalf of Engineers Ireland about the graduate membership. So if you're watching our YouTube video and you would like to kind of ask some questions, I've actually started a forum on our student and graduate section where you can kind of log in, click on the topic, and you can ask any questions. I'll put a link in the description below in the recording, just so you're able to access that. One of the big things about today is just to remind all our attendees and anyone watching is that we're giving free graduate membership to all the graduating engineers, the class of 2021. It's really important that you do take it up while it's going free. And we have extended for the 2020 graduates, there's an opportunity to join Engineers Ireland at €70, seeing as you were so disrupted with the coronavirus. So yeah, just a quick plug about our free graduate membership that's currently there. You have to apply for a student membership before you become a graduate, and a lot of people ask us, how do you do it? It's really quick and easy. You just log into your student profile on our website, and just over next to like the salary survey and all the different resources, you click on become a full member. And if you're wondering if you are a full member or not, you'll know you're a full member already or a graduate member if you have access to the My Cpd tab. That's usually the quickest way of finding out what kind of grade you're at. To give a plug for why you might join as a graduate engineer, we have loads of cool opportunities for graduate engineers up on our jobs desk. So it's a great way to find out about different opportunities that are available for you as you graduate. I gave an advice session recently to the DCU class of engineering class of 2021, and I thought I might just iterate some of the points here of kind of working towards your next objective, like perhaps in the next in the first 5 years of your career, if you have your master's and your accredited education, you might want to become a chartered engineer, or you might want to apply for any of our professional titles, such as associate engineer. So work towards your next objective now that you've finished college. It's a great way of keeping your career on track. Great also to remember global opportunities. You have a fantastic degree that can bring you anywhere in the world. I'll go on to that in the next slide. But just remember that you've great opportunities all around the world once the world opens up again after this coronavirus. Don't forget to keep up with your continuous professional development. It's so important to be logging all the learning that you're doing and to keep an accurate record. And that'll be especially important if you're applying for a professional title in the future. And then finally, join a network. I know that's a theme that Luciano will touch on during his presentation, but it's really important to have like a network of peers or other professionals that you're part of. So yeah, the global network that Ireland's part of, we're a signatory of the Washington Accord, meaning that if you have an accredited Washington Accord degree, that you will be treated as equals with all the countries here in light blue around the world. And we're also part of the ENAEE, which means that you have great European recognition as well. So just remember, there's fantastic opportunities available for you overseas all around the world. To say about CPD, like so important, there's loads of different ways that you can keep up with your CPD. Even taking tonight's event as a professional body activity, we put together these two presentations on digitalizations through two kind of esteemed engineers who are giving up their time. Don't forget to log your CPD. You can do that on your membership profile. This is an example of my one. I haven't been very good with logging my CPD, but what you would do is you just put in your activity name and the hours will go down as you do it. And you can see all the different CPD opportunities that are coming up as well in that. I mentioned joining a network earlier. There's loads of different regions, divisions, and societies in Engineers Ireland. Really want to give a plug to the Young Engineers Society. They're doing fantastic work, doing different presentations and webinars. And I know they're super excited to go back to in-person events once it's safe to do so. And yeah, I'm approaching the stage where I will introduce our first speaker of the evening. Luciano Priyallo is an Argentinian industrial engineer. He's now based in Dublin, working at Accenture as a junior GPS analyst. Sorry, I'm tripping over my words. He's also a global shaper with the World Economic Forum, and he's a founding member of the US Alumni Buenos Aires, an investigation assistant at CEPAI, and a tutor at Tubeca, Argentina. Back in Argentina, he worked at Priyallo as an industrial quality analyst, and during his college career, he took part in the Washington Model Organization of American States in 2019, 2020, and 2021. In 2018, he was awarded a Friends of Fulbright scholarship to study for the summer at the Walton Business School at the University of Arkansas in the US of A. So I'm going to stop sharing my screen now, and I'm absolutely delighted to be handing over to our first speaker of the evening, Luciano. Luciano?
Thank you, Michael. Well, first of all, I would like to welcome every one of you. It's a great honor for me, and I would like to especially thank Michael for the invitation for giving this presentation at Engineers Ireland. So I'm going to share my screen at this moment. So my presentation is going to be focused on how my engineering degree has prepared me for anything. So resilience during COVID-19 times, a boring presentation by Luciano Priyallo. Yeah, this is going to be some sort of boring, so I'm sorry ahead of time, but I apologize. So basically, as Michal mentioned, I'm an industrial engineer from Argentina. For those who don't know where Argentina is, it's a country in South America, southest countries of the world. You might know Argentina for Diego Armando Maradona, like a famous soccer player that sadly passed away last year. It was a great shock for my country, but also you might know Argentina because of Lionel Messi, the GOAT. Although maybe some of you may think that Cristiano Ronaldo is better, but well, I'm Argentina. I had to be honest. For me, Messi is the GOAT. And if you are not into football or soccer, you might know Argentina because of the Pumas, the rugby team, our national team for rugby. And here is a picture of a match against Ireland that, to be honest, I don't have the slightest clue on how the outcome of this match was, but I bet it was an entertaining match, as generally Ireland and Argentina are a match against too. So as Michal mentioned, during my college years, I was awarded a Fulbright, Friends of Fulbright scholarship at the University of Arkansas. There is a picture there of me with the other Argentinians that we traveled there. That picture is in Little Rock, not in Fayetteville. That is the actual capital of Arkansas. And then I also I took part of the diplomatic simulation at the Washington model of the Organization of American States. That, just like to make a little highlight, this scholarship that my university gave me was more focused into lawyers or into economists. And I was the second, in more than 20 years, I was the second engineer to be part of it. So this is basically like a little spoiler about the presentation on how, like, engineers, after all, we are able to do almost basically everything. But well, that's a picture of the actual model in the headquarters of the Organization of American States. That is basically like the United Nations, but just for the American continent, from Canada to Argentina. So regarding my professional career, and besides the volunteering that Michal mentioned, I started my professional career as a technical support role at MSA Group. That this was related to my high school degree, that I'm an electronic technician. Then I worked as a data entry operator for Indra for the national elections. I was uploading the ballots information from a national election. That it was something really interesting, because it felt like you are like at the barracks, like defending democracy. So it's a very interesting thing to do. And finally, I managed to get a job in the engineer business as an industrial quality analyst at Pirelli Tires, like the Italian brand that has one of its main factories worldwide in Argentina. So although I was happy at my job in Argentina with my friends and family, there were some reasons that made me plan to leave Argentina. For example, the highest inflation that we have in almost 30 years. That, okay, these numbers are even before COVID. So you can imagine that with the pandemic, these numbers even have gone worse. Like a poverty rate that is constantly increasing, and especially, and most of them all, insecurity. Like 90% of the people that used to live, or that still live in my city, that we are called porteños, from the capital city of Buenos Aires, felt unsafe while walking on the streets. So that's something that I highly value my life. So this one was one of the main reasons of why I decided to move from that. So by the end of 2019, I decided to book a flight to London. I booked a bus from London to Liverpool because I had to plead guilty. I'm a Beatles fan, and I was not going to let the chance go away from visiting Liverpool. And even I booked a ferry to come to Dublin. But something that I think happened, right? Like a new virus appeared back in January 2020, and in theory, it doesn't appear to be really spread by humans. But I think that the time, after all, it proved, and in this case, the New York Times wrong. So I remember back in the day, like when the first lockdown began back in Argentina around March. How much will this last? Like 1 month, 2, 3? Yeah, I mean, I was a little bit of a clown, right? I know that a lot of you must complain about like how the Irish government has established the lockdown back here, but I have to be honest. I mean, Argentina had almost 7 months of a strict lockdown. Like literally, you were not able to leave more than 5 blocks from your house. So we were like the never-ending quarantine back in Argentina. So basically, the coronavirus made all my plans suddenly disappear. If I have to make a recap and I go a year ago today, I was more than 6 months into unemployment because I resigned from my job by the end of 2019. I was not able to leave Argentina because of all the restrictions, and I was completely unsure about my professional and my future overall. So I remember something that a professor told me back in the day. You should always be able to forecast and prepare yourself for the worst case scenario. If you do that, nothing will surprise you. If you have seen Games of Thrones, this might be similar to a quote that Littlefinger said, but I have to be honest, like this quote was older. At least my professor said it to me before the seventh season of Games of Thrones. So at this time, I reflect a little bit about this quote, and I discovered that everything was my fault. I mean, how I was not able to predict a pandemic? I mean, this guy could. Why couldn't I? I mean, it would have been a little bit different if I know that a global pandemic was coming. So let's try to be a little bit serious, okay? This quote that my professor told me, if you really think about it, it's not so different from a FODA analysis. Oh, well, sorry, a SWOT analysis. Apologies for my Spanish and also for my English. And a strengths, weakness, opportunities, and threats analysis. Or even, it's similar to a risk analysis matrix, where you have like the likelihood and the impact that it has. So all the things that it might seem normal to us, like a pro-cons comparison, a price quality analysis, a technical approach to things, or an emotionless or cold-hearted approach, although it might seem normal to us, it's a process that we have mastered over and over the years. A new way of thinking, a new brain structure that as engineers we develop. That is called the engineering mindset. These sources what I'm going to say is from this book, Apply Minds, How Engineer Thinks, that I have to be honest with you, I haven't read, but the topics that it takes are very interesting. So the engineering mindset is basically that we have the ability to see a structure where there is nothing apparent. Yes, like thinking everything as a process. That is something that is not at all, people are not commonly used. Like the brain structure, the way of thinking for them is not the same. Also, we are able to adapt under certain constraints. In this case, pandemic. But in sometimes we manage that if we don't see as a first-hand approach some sort of limitation, we try to think about the future, about those limitations that might appear, and we try to prevent it for them happening. And we also understand trade-off. We understand sacrifices. We understand that we sometimes have to let something go in order to achieve a greater goal. So these are the main three things that as an engineer with our studies and our practices and our daily job, we manage to foster with the coming years. So we all know that new times are coming. We know that there is a lot of uncertainty ahead of us. We have the fourth industrial revolution, Internet of Things. We have artificial intelligence coming into play. But we should remember what Ono taught us. For those who might not know who Ono was, he was an industrial engineer, Japanese, and a businessman, that he was the father of the Toyota production system, basically the lean manufacturing system in the United States. That's the Japanese word kaizen, that it means change is good, or good change, also known as continuous improvement. So change and facing new obstacles is the only way that we manage to get better at the things that we do, to manage to continually improve our life and our professional career. Now, I can actually recommend you a book that I actually read, that it was The Goal, but by Goldwright. That this book has been considered one of the 25th most influential business management books. And it basically talks about the theory of constraints, that although it's a theory that is applied to industrial processes, it's basically always looking for the slightest piece of a chain and trying to solve it in order to foster the whole system. So I always think about this book as a way of life, more as an approach to face processes. And remember that the mindset that I mentioned is very valuable for the market. That's why after arriving to Ireland in September 2020, after a long lockdown back in Argentina, waiting for my PPS number for more than 3 months and sending hundreds of CVs, during April 2021, like 2 months ago, I managed to get a job as a junior global product support analyst at Accenture. That is actually an IT job that is not related at all to what I've studied back in Argentina, but is related to my critical thinking skills that I did develop because of being an engineer. Therefore, after going through 2020 and more than 6 months into 2021, I truly feel that in these strange times that are still in, being an engineer has prepared me for everything. Thank you so much for your time.
Luciano, that was absolutely fantastic, and I think a really strong and powerful message to be giving the class of 2021 who are joining us this evening. And I definitely think that in terms of your ability to utilize the way that you've been kind of taught to think as an engineer and kind of apply that to your own kind of new career path in digitalization is really really great message for all those who are joining us and viewing. So I'd like to invite Pork to join us now. And just as Pork is putting up his screen and sharing screen, I might just introduce him formally. So Dr. Pork Quirk, who's a chartered engineer, is an associate director with Murphy Geospatial, Ireland's leading geospatial company. Pork heads the Specialist Engineering Services Department in the company, which undertakes specialist rope access, confined space, bridge scour, UAV, ROV, and CCTV inspections on critical infrastructure throughout Ireland. Murphy Geospatial are leaders in digital transformation through the capture, verification, and governance of accurate geospatial data to deliver the digital.
Yeah, thanks everyone, and thanks to Luciano for a very entertaining and presentation. It was very good, and I wish him best on his career. Hopefully come back to engineering at some stage with a critical thinking like that. So I just said I'd give a brief overview of my career as an engineer to date. I graduated from UCD in 2005 with a degree in civil engineering, and times were good back, so I went straight into industry. You didn't need a master's on the path. So I worked with our St. Dunleary for 4 years as a graduate and engineer. I was in the roads and transportation department, so I got to work on various road schemes, from very small roads to motorways. So on the original Metro project, which goes to show how old I am now, the original design for Metro before it was re-envisaged as Metrolink a couple of years ago. So then I moved to Australia and I worked with a company called Oricon, similar to RPS, a multidisciplinary engineering firm. And I worked for 3 years as a senior design engineer on airport projects. I returned to Ireland in 2013 and I joined Irish Rail as a research engineer, and I undertook a PhD investigating railway track settlement. I'll speak a little bit more about that. As part of a well-funded Super Again project, meant we were able to purchase equipment to test our theories in reality out on the track, which was very, very interesting. And after that ended, I joined Murphy Geospatial because I really liked the gathering of verified data and using that data to make engineering decisions. So I thought Murphy at Geospatial was a very good fit for me. And recently I was promoted to Associate Director, and I'm now head of the Specialist Engineering Services Department in Ireland and the UK. Years in kilometers of engineer. I was lucky to be involved in this project because it involved every aspect of engineering, the geometric design of the road, the pavement design based on the traffic, the drainage design, involved with meeting the client, involved with compulsory meeting with the public consultation. So it was an excellent project to get lots of different varied experience. And that actually wasn't started by the time I left, but it was completed recently, which is great to see. And I've driven this road a few times, and it's actually great satisfaction driving along a road that you've designed or was part of design. When I moved to Australia, I got involved in airports, and just incredible experience there. I was involved in a huge amount of airports projects in Australia and in around the Indo-Pacific area, one of which was Perth Airport. We designed lots of taxiways and this extension to the international terminal, and designed all the terminal. Very challenging and rewarding project there. And also there was a brand new runway in the jungle in Papua New Guinea to support the development of a LNG plant refinery. And this project was just a crazy project to be involved in, but we managed to bring the project in after a couple of redesigns. We had to redesign as the contractor met problems on site. So really challenging, lots of critical thinking involved, and really had to put in long hours and come up with design solutions to help the client meet what was then on the critical path for the entire project to deliver billions of dollars worth of gas to Japan. So a very, very interesting project. When I came home, the challenge I was met with was to undertake a research project. And the research project was to detect railway track settlement and bridge damage using sensors that are embedded into trains. So you can see along this track alignment here, there's a vertical dip about 100 meters away. It was to measure the accelerations of the train, the vibrations of the train as it moved along the track, to see if we could infer that there was a dip in that section of the railway track. So we managed to prove it. And as I said, we had a generous budget, so we were able to install sensors on a train. I got into the Portlaoise train depot, and we raised this 300-ton train up on these hydraulic jacks, and we started working underneath, which is a bit scary. Installing 12 sensors, and got data from the field and proved the concepts that I had modeled in MATLAB in UCD. So a very, very interesting project, and really great outcome with the results as well. So following that, I joined Murphy Geospatial. So just a quick few points on digitalization in engineering. It is now absolutely everywhere. I haven't written on a piece of paper in about 3 or 4 years. It's all, and COVID has accelerated this. It's all virtual meetings and augmented reality, use these tools to make decisions. We have BIM, we have CAD, we have Internet of Things sensors, augmented reality. There are tools available to us now to make informed decisions every day, and it is absolutely everywhere. So if you want to become an engineer, you have to adopt, and like Luciano said, move with the times and become really skilled at digital tools. Machine learning and artificial intelligence are also empowering huge changes in the industry, and it's there's no point resisting it. It's going to be huge for yourselves in your career, just becoming graduates. I'm struggling to understand it all myself, and I'm 15, 16 years out of college, but it's definitely the way the industry is going, and we're starting to apply that in our own business. But the decision that engineers make is only as accurate as the information that it's based on when you're relying on these digital tools. And validated, verified engineering data is absolutely critical in any part of the process of a design or construction or management of an asset. And this goes from materials data and their specifications, equipment data if you're putting in pumps in a water facility, for example, and their specifications, and also the geospatial data. Where is that element located? What is its level? What is its precise location? It is critically important to make the right decision. This is a modern working environment. You have these gigantic interactive screens, 3D models that can be rotated with a hand gesture, and elements of that 3D attributes assigned to it, and metadata that feed into analytic systems, and artificial intelligence is applied to support the engineering decisions. And video conferencing tools. Every engineering firm where you go to now in your career, they will be well set up with video conferencing facilities to enable working between different departments located all across the world. So it's a very exciting time to be in the industry. So a bit about Murphy Geospatial. They were formed in 1983 as Murphy Surveys and just did land surveys at the time, but developed so many different services along the way. We're now the largest geospatial company in Ireland, and we've a significant UK operation in London and Manchester. And the unique part of the company is we have that scale that we undertake all the largest projects. We have a huge amount of staff in Ireland. So if there is a really big piece of infrastructure to be built in Ireland, we're generally have the scale to deliver, and we get involved and win the contracts to be part of the projects. We have a strong history of innovation. The company was one of the first in Ireland to introduce laser scanning as a service, and has just gone on there because the laser scanning opens up with BIM and everything, opens up so many different services that can be supported with the initial laser scan. We're also now pioneering the role of geospatial manager for large organizations in Ireland, which basically means asset owners now have a huge amount of digital information. How do you manage that effectively? And we've developed a portal and different systems to help manage that for different organizations, help manage their geospatial data. And that can be integrated with APIs into other management systems. So the company vision is to be the first choice partner for geospatial certainty. A great vision to have, and we're really living that vision currently. And this is a snapshot of services. I won't go through all of these, but you can see the traditional services on the left side. Then we have geospatial engineering, where we're involved with digital setting out on sites. We're involved in Lewis Cross City Works, for example, helping to set up the alignment, how to be very precise for the contractor. We inspect a lot of critical assets around the country, and we do a lot of structural environmental monitoring. We also consult about what the best approach might be to a survey problem or a solution, providing a solution to clients. And we also deal with a lot of data. We generate a huge amount of data every day. So we have developed platforms to support this data and visualize that data. Nothing is printed on paper anymore. As I said, it's all through digital platforms. And more of those digital platforms are moving online onto SaaS solutions. So we're really adopting and going along with that journey, and we see the benefits of that. And it helps to maintain a digital twin of the asset life. So you're going to hear the digital twin throughout your careers. It enables someone to understand the performance and predict the deterioration of, say, a road or a bridge or a building, or monitor its performance, but digital twin to be the framework for that. And if you build that digital twin, it needs to be verified, it needs to be accurate. So accurate geospatial data enables good planning, good design, good construction, coordination of all of that. Ownership with land right in the city centre, each centimetres count on these large sites to optimize the floor area of buildings and their boundaries. It enables digital platforms and frameworks for facilities management in the in-use phase of an asset. And it can also be used for intelligent building control. IoT sensor, this is all integrated now into buildings where it detects movement to turn on lights, or it detects temperature to vary the heating, but doing that on a massive scale, like on a hospital or a site or a prison or something like that, all created automatically or controlled automatically with IoT sensors. Also enables a remote and on-site virtual and augmented reality experiences, so people can visualize something before it is constructed. And the result of all this verified geospatial data is an organization is empowered with verified geospatial data, which serves as a single source of truth for all their assets. And you'll hear that term over and over. Single source of truth is so important. If there's multiple different conflicting data sets, there's a chance of problems and conflicts and issues arising. And this is where we're involved. Like if you join a government agency, you might be involved in the first part and the fourth part in strategy and consultancy about how to plan for the future and also how to manage operations and maintenance. If you join a design consultancy, you'll probably be in number 2, where you're working with the client to plan and create a detailed design, which is very interesting, great field to be in. And then if you're with a contractor, you might be in the construction side of things, on site, managing a construction project, making sure it's been built according to the design and in line with the client expectation. Where we get involved in all stages. So our data is used in planning, it's used in design, it's used for strategy. We're involved in construction sites with our digital construction service. And like I said, if you do a very accurate as-built survey, you can use that in facilities management softwares to really efficiently and effectively manage and reduce costs in the in-use phase. And the costs in the in-use phase, you might think construction is expensive. The costs of running an asset are 80% of the lifetime costs. So to reduce the costs in phase 4 is absolutely critical. So you can see here we get involved in all aspects, and what spans across all of that is the management of this data. How relevant is that data, say 5 years after it's been captured? Can it still be used? We'll go out and verify that yes it can, or no it can't. So that's a critical element, so that you can be confident that you're using the correct data to design something or manage something. So, you know, informed decisions are based on good data. And these are some of the tools that we use to digitize assets and create these digital twins. We have laser scanning, terrestrial laser scanners. We have unmanned aerial vehicles, UAVs, or drones, as you probably know. That's an oldish drone now. The technology is moving so fast in that space. We have robotic total stations, which is almost being replaced now by the terrestrial scanner in some cases. You have the vehicle mounted mobile mapper. So you have scanners, I think 5 or 6 scanners on that at different angles, put on top of a car, a bit like Google Maps, and just drives around at a higher accuracy than Google Maps currently capture. Really good for road design and road relines or road management. You can put them onto trains as well for railway applications. Then an indoor mobile mapper, which is a similar concept, but you just push it around a very large building and it captures all-encompassing laser scan and colored 360-degree imagery of a factory floor, for example. Ground penetrating radar allows you to see stuff buried into the ground, like utilities or buried tanks or attenuation tanks, things like that. Really, really useful to make you see what is occurring underneath the ground. And this, combined with an augmented reality deliverable, really brings the underground to life, and I have an example of that later on. Also, robotic boats to actually do surveys on rivers and lakes, bathymetric surveys for the depth of the rivers, which is really useful for flooding and maintaining shipping channels and things like that. To give you a few examples, and I'll try and stay within the time. With UAV, we do 2 services, photogrammetry and laser scanning. So with photogrammetry is all about creating, using pictures to create accurate models and elevations of a building, or 3D models. So this is the Guinness Storehouse, as you probably know. The Guinness Storehouse is undergoing a renovation, or this whole district is undergoing renovation, and they wanted to get facade surveys of the Guinness Storehouse. So we flew a drone around and took thousands and thousands of pictures of a good overlap and flattened them out into an ortho elevation. And so that's one of the elevations of the south facade of the Guinness Storehouse, but you can measure very accurately every element on that facade. And I'll give you an example of that. If you look at this detail here, all of that is geospatially accurate. So you can measure every brick, everything. If there was something that happened to this building, and actually something similar happened with the Notre Dame Cathedral. When the fire happened, everyone thought it was an absolute disaster. But a company had laser scanned the interior of Notre Dame Cathedral a couple of months before the fire as just a coincidence. And now they have that data set to faithfully recreate the interior. So it's such an invaluable data set to have. This is the clock from the Primark building, Pennies, in Belfast, which burnt as well a couple of years ago. And they were worried that the facade would fall because it's no longer structurally supported after the fire. So we went up with a UAV and took thousands of images again around the clock tower and got this amazing detail of all the architectural finishes, so that they could be, if it did fall down, they could be recreated as well, and it gave that digital record of that asset. We also get involved in special effects. So this is Kilruddery House in Wicklow, and it was used in a Netflix production. I don't know if it's been released yet, and I'm not sure of the name, but this is a photogrammetry model from drone pictures, just from pictures, all stitched together in software, Pix4D software. And it's not enough, like for this particular project, it wasn't to the detail that you would itemize everything and create a facilities model out of it, but was used for CGI in a Netflix production. For laser scanning, give you some examples. This is the OPW headquarters in Trim in County Meath. And this is an amazing building, really, really unique. It's made to look like a Celtic brooch, really cool piece of architecture. But they wanted to optimize the floor plan and create more space. So we did an entire laser scan of the building, but traditionally that would have been presented on a 2D drawing, but we created a 3D BIM model of that entire building and then presented that to the client, but also paid particular attention to the finishes and surfaces and created this really photorealistic BIM model. You know, it won awards at the time for its quality. And you can see shadowing effects. You know, you can make it look very, very almost realistic looking model. But that was used then to plan a relocation of the office and reconfiguration of the office there. But that model could equally just be used if you create every element in the BIM model and assign attribute data. It can be then used in facilities management. So there's huge possibilities once you create the BIM model to use it for other uses. And one of these, this is an example of a project that we did for Irish Water. It's a water treatment plant in County Leitrim. And it's on an elevated site, so we got the topography of the site, and any element of the site was scanned and modeled and rendered then to produce this really impressive visual. But more importantly, like, this looks great, but what's the use of it? Like, more all the tanks, all the pumps, all the elements are can be related to Irish Water's asset management system and their unique identifiers. And, you know, materials, pump types, date of installation, date of last inspection can all be put in as attributes into the BIM model and make it a really useful facilities management tool. And also, this model is geospatially accurate, so it can be used to, say you wanted to place another vessel in that room there, you know the exact dimensions available at your disposal, and you know where power outlet is, you know where electricity supply might be, and et cetera, et cetera. So just the models are just hugely, hugely valuable assets to have. This is an example from our London office, I think our Treasury building or something in London, but amazing detail on the inside. That again, it can be, I think this was used for a virtual tour on a website, you know, so really, really accurate and really, really nice detail captured by laser scanning. But laser scanning is also innovating, and this is a mobile mapping, indoor mobile mapper. So you push it around it and it generates a point cloud, really dense, millions of points, defining the geospatial geometric layout of indoor spaces. So this is an underground car park. It's used for manufacturing facilities when they're planning reconfiguration of their workflows. It's got 360-degree imagery as well, so you can color the point cloud and make it look realistic. It's all hosted on an online platform that you can tag different materials, measurements. You can make measurements to see if certain things will fit in certain places. And just, it's all virtual, so you can collaborate with any design team around the world. An example of that was for Dublin Airport. We worked with a German company on the baggage handling system. They only had to visit Dublin, I think, twice to do their design. Everything else was done with data we captured for them remotely. So I'll just move on in the last few minutes to inspection. So I'm head of the Specialist Engineering Inspections, Specialist Engineering Services Department, I should say. And we get involved in a lot of inspection in difficult to access areas. So consulting engineers would do inspections where it was easy to access and they can get to see the asset and do a visual inspection. Where it's not that easy to access, we have trained people to get up into precarious positions to assess the condition of these elements and structural elements of bridges. So You can see some people hanging off ropes there to do a visual inspection of the stonework and also the steel elements on the bridge. We're also combining this with UAV. So what we do is, you can see our pilot there has brought a headset that has a live feed from the UAV camera, and they can see exactly what the UAV sees as he's flying it. And the engineer, this is an engineer, this engineer can instruct our pilot to fly to an area of interest and put a holding pattern on if they want to view something in greater detail. It's all recorded, but at least the engineer can instruct the pilot where he is most interested in seeing. And this is an online video now of the results at this bridge, and I think it should play automatically. So yeah, so you can see this is the Boyne Viaduct in Drogheda, one of the biggest bridges in Ireland. We surveyed it last October, fantastic results from the UAV, and the client was really happy with this. It allowed them to pause at any location and make an assessment on things like vegetation, wall staining, cracking on some of the masonry elements, and avoided the need for the rope access inspection to drop at every couple of meters. They just dropped at specific areas. You can see the quality there. You know, UAV is just changing how we do things in a number of services. This is like a UAV, but it's underwater, more submarine, and we recently purchased. Again, this is a railway bridge, but it's impossible to access because it's always submerged. It's a siphon bridge, so there's a pressure pushing the water through, and this hadn't been inspected I don't know if it was ever inspected before until we came with the submersible and dived in. It's got high-powered lights, it's got an onboard camera and a little grabber, and a 150-meter long tether. And this bridge goes underneath the railway and the canal. So we were able to get the ROV in quite a bit of 2 meters per second flow and pick up lots and lots of really useful footage for Irish Rail and find some defects and, you know, let them if the enough condition. More recently, we've moved into creating models of bridges and more difficult to access structures. So this is a bridge over water. It's not like we can set up a laser scanner in the water. So what we did was we put a laser scanner on a boat and we drove the boat in a zigzag pattern. You can see the zigzag pattern underneath. We drove under each arch, and this is using a SLAM technology, simultaneous location and mapping, which needs movement to keep a track on its location. Really interesting technology. It's a ZEB scanner is the name of it. So you have to go zigzag through the arches and loop back around to finish the loop, and you'll get an accurate geospatial reference of all the scan data. From that data, you know, we got the great detail on the underside, which is and they were planning a rehabilitation of this bridge. And from that data, we're able to build a really, really highly accurate model of the bridge, enabling a consulting engineer then to take this model and make really reliable design decisions using that creation, you know. One more video of a bridge related service that we do. We have an interferometer. This is a radar, a microwave that we point at an asset like a bridge. So you can see the radar head, its little yellow head here. It's emitting a microwave signal against the bridge and measuring the return. And as the bridge goes across, you can see the deflection of the bridge is measured. Now, this deflection is 6 millimeters. That's really, really small deflection, but it's able to measure it at 0.1 millimeter resolution, which is amazing. 2 lines on this bridge. This is the bridge over the Liffey in Dublin, the Loop Line Bridge, or the Guinness Bridge, as some people know it by. You can see that the west side is the side that the train is on, has deflected more than the east side. So you can see the bridge is actually twisted due to the load that's on the bridge. And this radar is that accurate that it can pick it up. So that's me there, very happy with these results, and that we got a good result for our client. So this is pioneering in Ireland. This hasn't been applied on too many bridges yet, and we're leading the industry, trying to you know, get more information for asset owners like Irish Rail on the performance of their bridges under load. Finally then, utilities is a big part of what we do. So visualizing what's beneath the ground using various methods, but mostly ground penetrating radar, which is really useful technology to find pipes and conduits and tanks and all this buried infrastructure that is critical to everyday life. So the difficulty sometimes with utility surveys is visualizing it because it's buried underneath the ground. So we have created 3D models now of buried infrastructure, but we are marrying that up with augmented reality and recording the augmented reality experience for our clients. So you can see here, there's a GIS representation of where one of our site operatives was walking and recording the information. We can go to any part of that model and play a recorded screenshot of the information that they saw through a augmented reality application called Site Vision. So you can see really good alignment with the manhole covers in green there, in green on the left. There's alignment on green and in red on the left there. That's electricity. Green is communications. Purple is surface water. So it really, and the engineer doesn't have to be on site to see this. He can just refer to this and go to any part of the map. Recently, we added attributes then as well, that if you click on any of the pipes, you can tell if it's electricity or what diameter it is and things like that. So this is really, pioneering new deliverables for the clients. So that wraps up my presentation. Thanks for your attention. If you have any questions, we'll take now. And we are hiring. We have a very interesting graduate role actually at the moment that if you're interested in, maybe Michal might share the link to the advertisement of it. It's to analyze and put a monetary value on the geospatial data that we are capturing, and there's a chance that might be a secondment across the water to the United States as part of it. So yeah, if we have any people interested on this call today, I'd be happy to speak with you. Thanks very much.
Mark, that was an incredible presentation, and I know one of the taglines that we use in Engineers Ireland is all about your career starts here, but if there are any graduates who are looking for somewhere exciting to start their career, I would definitely wholeheartedly endorse that opportunity. I think you've put together a really great offering, and it sounds like a really cool company on cutting edge side of digitalization. I'm going to end the recording now and move into our unrecorded questions and answers session. But before I do, I just want to thank both our speakers for 2 excellent presentations, and we really appreciate it. So I'm going to end.